guys, science is going to be pretty quick today. Just make sure you have out your packets and flip right here with me to page 3. So when I made these packets last year, students had the textbooks they needed, hence my textbook icon. But of course, I didn't give them to you before we got socially distant. So we're going to just make the best of it. And I'll just give you the answers. How about that? AKA, I'll teach it to you instead of the textbook teaching it to you. All right, so up top here we have a nice reminder. Just we're staying in the realm of solid to liquid to gas. And today we're focusing on a phase change from a solid to a liquid, which is called melting. So right here we have 2 blanks. And I would like for you to spell out melting point in super drippy block letters to just try to fix it in your mind. Those letters were solid blocks, but they were made of ice, and now we have a hot hairdryer going at them, and they are melting. And more about melting point in just a second. So that's a specific science term we're going to learn today. Solids melt. Think about ice. Think about wood. Think about metal. All those things can melt. Wood can melt? More on that in a second. When you add blank, usually heat, what do you need to add? I'll fill that in just a second, but let's keep going. You'll see why. And break up the tightly packed solid molecules into looser liquid molecules. So I've drawn a little picture of who knows what molecule that is. But when they're a solid, look how tightly packed together they are. And then we add in some mystery word right here, and they break apart and they're farther apart. They lose their structure. That makes sense. Look at this beautiful ice cube, and it loses its structure. Actually, ice is a terrible example. Remember, we learned that ice molecules in their solid state are actually farther apart than in their liquid state. But let's say this is a block of cheese, cheddar cheese, and then we put it in the microwave and it melts into gooey cheese, right? What did we add to get that solid piece of cheese to gooey nacho cheese? Heat energy. We added energy. Go ahead and write the word energy right here. And it's usually heat energy. I could put that block of cheese up to a light, like a light bulb, light energy, and it might change into a liquid a little bit, might melt a little bit, but that's probably because of the extra heat energy that light was giving off, right? Number 2, materials melt at different temperatures. And this is a good thing, right? So water melts at room temperature, right? If you leave an ice cube out on the counter, it'll eventually melt. You don't need to add it into the microwave to get it to melt. A block of cheddar cheese might get a little bit of a sheen of moisture on the top of it, but if you left it out on the counter, it wouldn't automatically turn into nacho cheese. It would need to add extra heat to become liquidy. So every material you see can melt, but it just needs a different temperature to do it. Pop question. Let's test this thing that I've just told you. See if you really believe me. Number 3. Can sand become a liquid? Sand? I want you to think back to a time you've been to a lake shore or a beach or tiny little pebbles between your toes, and think about that in liquid form. Does that seem possible? Predict real quick for me. I'm going to tell you in 3, 2, 1. Yes. Even sand can become a liquid, but you have to heat it up super hot, right? Which is good because otherwise we'd have a liquid beach right next to the ocean. And you may have heard of liquid sand. It's glass. When sand gets heated up high enough, we get clear glass and glass blowing, and then it cools and hardens again until it's transparent. All right, go ahead and flip to page 4. So now that we know that anything will melt, let's have some fun. What temperature will it melt? Because, some of these things, look here in our box, you might have thought, they can't melt, right? Water, a pebble or a rock, chocolate, gold, candles, or wax. And I've already done lava for you as our example in the middle at 700 degrees Celsius. Now, real quick, well, this should be a review, but we in the United States tend to use our temperature reads as Fahrenheit system, but for this scale, we're going to use Celsius for our system. So let's come all the way down here. Your paper has blanks, mine has the answers. Here we go, let's fill them in. As we said, water melts at room temperature. So it doesn't need a whole lot of energy to shift from its solid state to its liquid state. And that's good. That's good because otherwise our oceans would mostly be ice and it would be a lot harder to swim in there. And a lot of other things. The fishies would not be able to move around. It would be hard times. So thanks, water, for being melty at 0 degrees Celsius. Moving on up the chain, we have chocolate. A little bit harder to make chocolate melt. But I can tell because, like, my mom was super cool. She let me microwave some chocolate and dip some strawberries in there, and it was super tasty. Or insert whatever thing you did. Maybe you made brownies, but you've seen melted chocolate before. Maybe you went to a fancy party and saw it. So we know that chocolate melts. Chicken on up to 80 degrees Celsius. Candle wax we know melts because I definitely poked my little finger into that candle that one time and it got hot and burned me and I regretted it and didn't do it again, right? Then I have to, as I move up this scale, I have to put more and more and more energy into that solid material before it will turn into a liquid. So way up here, hot, 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 at 700 degrees Celsius, we have lava. Lava you may think of as liquid, and you may have seen those really fun pictures of like glowing orange spouting lava, and you don't really realize that really lava is the liquid form of rock, right? It used to be rock. It's like magma of the Earth's surface. It's a little bit less dense than rock, like what you dig up in the ground, but it's close. It's closer to rock than sand. I'll put it that way. Okay, moving on up here to 1,000 degrees centigrade, we have our actual pebbles or rocks. Now, I really hope none of you have to experience a temperature at that, because if it can melt a rock, let's not test what it will do to you, right? Let's not get in that arena. But you can melt rocks into liquid. 1,064 degrees centigrade is when gold can become liquid. Now, you might have thought like all this zone is just like fiction. Like what could possibly be that hot? Well, fire gets pretty hot, guys. And gold is good at being liquid. If you think about if your parents or if you've seen someone with a gold wedding ring or jewelry, gold doesn't grow in the ground in circles that we can fit on our fingers. Like we have to melt it down, pour it into a mold, and then it's able to be shaped into beautiful different things. All right, I just wanted to give you guys, some examples because I feel like if I just threw out there, anything can melt, you'd be like, a mountain can't melt. And the weird thing is, technically, if we put enough energy into it, even a mountain could melt. All right, guys, I hope you enjoyed today's science quick preview. Get excited for Thursday. We're going to be making homemade butter. That's my teaser. All right, hope you guys have a great day.